As we're talking about combining functions, recall that this is when you will be given more than one function. So perhaps I have f of x, and then here an equation for g of x, and I'm being asked to add or subtract, multiply or divide these two functions. And as you can see, that just simply means to, whatever the operation is, take those two functions and perform that operation on them. So that would require you then to simplify. If I'm subtracting, I would have to distribute that negative sign. If I'm multiplying, I'm going to have to FOIL those functions and so on. But that is the four operations as I combine functions. Now, what we're going to focus on more than anything else in this section is something called composite functions. And a composite function simply means that one function is the input for the other function. You're actually plugging one function into the other. And we can see that expressed in a couple of different ways. You maybe remember fog and Goff. This little symbol here with the open circle, it looks like a multiplication, is telling you that you're dealing with a composite function where you're plugging in g of x into f of x. That's a little bit more seen a little more clearly in this notation, where inside of f, you see the entire function g of x plugged in. So let's do a couple of examples real quick. I am being asked in this problem, I've been given my two functions. Here's f and g, and I'm being asked to find both f of g and g of f. I'm being asked to state their domain, which we're going to wait until the next section. You can see the next section is called the domain of functions to talk about that, and then I'm going to determine if they're equal. So if they come out to be the same, then they're equal, and otherwise they're not. But as a quick review of how this works, in this first function f of g of x, I start with my function f. F is x squared plus 2x minus 1. I am going to plug in g for my input value in for f. So g is 2x minus 3. Oh, I forgot the squared. There we go. So, and then I just simplify. Don't forget, you do have to FOIL this all out. Hopefully you know the pattern. Save yourself a little time. And then distribute and add any like terms. And I get that result for f of g. Now in g of f, I do the exact opposite. I'd start with g. I know g is 2x minus 3. So in place of x, I place f. And then simplify. And I get g of f is right here. Now, again, we'll talk about their domains in the next video, but these are clearly not equal. F of g does not equal g of f. If they did, that would tell you they were one-to-one function, but they're not.